So the first thing we want to do when we start this unit, I just want to show you a formula. And here's the formula. It's on the cover of the booklet right here. So it says here that if you have a triangle, now you know how to find the area of a triangle. Everybody knows the area of a triangle. They should know it's half base times height. But that formula is not really helpful over here. You see that? Because we don't have the height of the triangle. We have the base, or maybe this is the base, but we don't have the height. So this formula is really a workaround from when you don't have that available. So if you have a triangle where you have a length, another length here, two sides, and you have the angle that is contained, think of it, when I say contained, I mean like a sandwich. See, contained? Think of it like a sandwich. So when the angle is like a sandwich like that, then this is the formula you use. This formula is going to be useful in some of the questions in this booklet. Not all of them, maybe some of them. If there's 20 questions in the booklet, you probably might use it in 5 or 6 questions. So it's not like the whole chapter. But I said to you that just with sine, cosine, tan, and Pythagorean theorem, and now this formula, you should be able to solve every question in the book. Now, some students here are going to say, sir, can I use the sine or cosine law? Yes. Yeah, it has to be contained. Yeah, that's what it means there. When it's sandwiched, it's contained. You're welcome. So some students will want to use more advanced trigonometry like sine or cosine law, where you don't have a right angle triangle, and it will simplify some questions. But for what I'm going to do, I'm going to answer all questions with only right angle triangles. Now, so like what I'm saying is, what I do might not be the most efficient answer, but it's the safest answer. Yeah, those are multiplication signs, Denny. Yeah, I needed to separate them a little bit so it's more easy on the eyes, especially when you're looking at a video. So yeah, that's enough of that. I'm going to start off with the first question. So like I said, I may take the questions and partition them into separate videos, or I might do them in groups of 3 or 4. So we're going to do, I'll tell you which questions I'm going to do with you in class. I'm just going to write the questions here. So when you're on your own, you can try them as well. Thank you, Matthew. So these are the ones I'm covering. 1 to 4, 6 to 9, 14 to 17. These are not some secret plan to like give you like the easy ones in class. There's a good mixture of questions here. There's some hard ones, some easier ones. But the ones that I skip, you're safe to say that the ones that I skip, you don't have to worry about for the test, okay? So if I skip something, I think you'll figure out, Matthew, which ones are tougher. They're usually the ones later in the book. But generally speaking, Matthew, and for everybody else, this booklet consists of medium to hard questions. So any question that you take out of this book is a medium or hard question to begin with. So I guess I want to say very hard is like maybe the better thing here. Okay, here's question 1. Nah, you don't need a practice run. I gave you tips. Remember? I always give you tips. Okay, I'm going to start on the question now, so we need to get focused on this question. So the question here is to solve for the angle S and the angle T. And then later on, you're asked to find what this length here is, X, on this figure. Now this figure is a trapezoid. And it's a trapezoid because this side here is parallel to that side there. Those sides are parallel because of these right angles. So our objective is to find all those things, and then kind of like a cherry on top, you got to find the area of the figure later on. So how do we approach this? Well, I'm going to show you a separate diagram that I use, And just for the sake of today's lesson, you'll see me copying and pasting a lot of typed or written solutions. These are from my personal notes, and it just makes the delivery a little bit more clean because you don't want to see me scribbling on this page too much. So the first thing I'm going to do is modify the figure. So that's the figure down there. You don't need the original figure anymore, so I'm just going to put that figure there. And what have I done here? I've introduced a new variable, a new angle here, theta, and that angle is going to assist us with finding the angle S later on. So keep that in mind. I've introduced a variable theta, and that'll assist us to find the angle S. But our objective is still clear. We're trying to find S, T, and X. So there's lots of ways to approach the question. I'm going to ask you to lead the way here. So what do you want to do here? What do you want to do here? Anybody have any suggestions on where to start with this question? The silence. Yeah, sine, cosine, tan. I agree with you. I agree with you, Denny. We're gonna get T. Actually, you know what we're gonna do? We're gonna get theta and we're gonna get T. We're gonna get a combo. So it doesn't matter which of those we get first. And to do that, just look at this triangle here in red, and let's talk about that triangle. It's a right angle triangle. What's this length here? The one that I've ticked off with a single. That's right, because of the rectangle that it forms above. So we can use SOH CAH TOA. Very good, Shalon. We can use SOH CAH TOA to get theta or T. So Denny, I'm gonna get theta first, if you don't mind. Hopefully, I don't doesn't bug you a little bit too much, but I'll get theta first. Thank you. So here's theta coming up. So keep in mind, I have my little workbook on my desktop that I've kind of typed up little things here and there so that I don't sit here writing on the screen because I will run out of time if I'm start to just scribble on the screen. So the first thing I did is I got theta. So I'm using cosine here. So cos of theta, here's the adjacent and the hypotenuse, and that gets us theta. How would you get T? How would you get S? Any takers? How do you get T? Now that you know theta, how would you get T? If you know this angle here, yeah, thank you, Shalon. You want to do the 180 rule. See, thank you, Janvi. Yes, Yufeng, yes. We're going to use the red triangle. And how would you get S? So how would you get S here? Now S is equal to, well, let's think about that carefully because S is weird. See, there's a right angle there, and then there's theta. So S is going to be 90 plus theta. So that's how you get S. And T is from the 180 rule. So that's very good work. So there you go. Do you mind that I'm just dragging in the typed information here? Is that okay with people? Okay, I promise you I'll go slow. I'm not gonna just throw typed answers at you and then you're automatically absorbing it. I remember I had a professor once that all they did was just drop slides of blueprints for an entire hour. And they just put blueprints. Every 10 seconds they threw a blueprint up. And I was like, what the hell's going on here? Never again. Okay, how do we get X? How do we get X? Well, let's look over here. Let's look over here. So this here, this is easy. This length here is 2106. It's just that. This is the length that we got to sort out here, down here. So what is that length? That little piece there. That's why I don't like drawing on these things too much. So that little piece there, I'll put a check mark here because that one's easy. There we go. So here's an expression that shows you how to get x. Yeah, just find the side of the red triangle, and Denny has the correct formula there. I'm going to use numbers, Denny, instead of letters, but what you did is correct. So let's take a look here. Before people start panicking, don't panic. Don't panic here. This part here is the check mark. And then this part here is the question mark. You see that? If you align it to the figure, let's use some colors. This is the blue thing. And we might have to call in some reinforcements here. Let's go with little magenta. And there's the other part, okay? So there you go. Now you have x. So the last part of the question is the area. Well, the area is the area of two figures. So how do you find the area? Well, you can find the area as two separate figures. We'll call this figure 1 here. And this is figure 2. Yeah, that's just a rectangle and a triangle. You could do that in your sleep. Yeah, exactly. So I've already prepared a piece of that as well. So I'm just going to do that here. So there's the area. So there's the length times the width. That's in reference to number 2, shape number 2. So let's call that number 2 there. Whoops, that's supposed to be a 2. And there's the 1 here. So you just add up those two areas, and then you're good to go. And some of these questions, you'll see that the author has suggested hints. You know, try this or try that. Sometimes the hints work for you, sometimes they don't. But usually the hint that the author gives is really, really good. And it's very helpful. But if it doesn't work for you personally, don't do it the way that you see it. Like, do whatever you like. I could answer this question with the area using some much higher level math, but with coordinate geometry, for example. But it doesn't matter. Just get the answer right. Who cares? So yeah, that's the first question. Just let me know in the chat there if you're ready to move on to the next question. I will post these solutions on Blackboard, by the way. So at the end of class, you will get these all typed up on Blackboard. Okay. I'll keep on going here. I don't wanna get sidetracked too much, but yeah. Not every question's easy. I don't want you to think every question I show you was easy for me to do. I remember when I started teaching at the college, my mentor, the person that brought me there to teach, handed me all the notes and said, "Here." And basically, I started in December. They hired me over the holidays, and then I started in January. And they handed me all the notes for this course, and they go, "You're teaching this in January." So basically, with a couple of weeks' notice, right? So I'm like, "Yeah, I'm good at math. I can do it." And then I got to this booklet, this book, and out of the 20 questions, I sliced through probably 18 of them in one evening. I could do them. I did 18 of them in probably a couple hours, few hours, because they're long questions. But then 2 of them gave me a little bit of trouble, so I had to actually think about them because I was getting the right answer, but my solution was way too long. So, like, the only thing I'd say is that getting the answer right is more important than how long it takes you. Because once you have the answer right, then you have confidence that you can do it better. But yeah, not every question is going to come easy to everybody, including me. They do take time, and they do take some creativity and patience. Geez, a lot of patience. No, no, no. I don't think that any singular person knows everything. I don't, because if I was like, if I had that attitude, I would never succeed. I got better at doing things because the things I knew I was good at fine, but the other things that I wasn't as good at, I would network with people that were I would network with people that I felt were stronger than me at the topic so that I could become better. That's true. Okay, let's keep on going, people. So, question number 2. We're gonna do question 2A, okay? We're gonna do question 2A because 2B is the same thing as 2A with a different shape. So the question A here is, what percent of a full circle area does an inscribed regular pentagon occupy? Now, when you read that question, you're like, what the heck is it saying possibly? But let me draw a picture, okay? Here's a circle, and here's a pentagon, 5 sides, right? I will present a much better figure in a second. But the question is saying, if I shade in the pentagon, what percent of the circle does the pentagon occupy? So take a look at the picture. Do you think it's 60%? Or maybe it's 80%? You know, we could play the guessing game here, but I don't want to guess. I'm just going to go for it. I'm pretty sure it's more than half, though. I think if you look at my picture here, you would agree that's more than half. So anyway, I'm going to show you a much nicer diagram with some additional information. I think we've actually seen a similar question in the previous chapter. So again, we're doing question A here, just A. So the question here is to find the area of the pentagon and the area of the circle. That's right. You want to find the area of the pentagon and you want the area of the circle. And then you're going to divide them. But what you notice is that there's no numbers. Like, I don't know how big this circle is. The radius is not defined either. So how the heck do you do that? In fact, the only number that you know is the 72 degrees. As you can see here, I can take the pentagon and divide it into 5 triangles. So what I'm trying to do right now is just focus on one of those triangles. I know the central angle, the angle in here is 360 divided by 5 because this is 360. This is a pattern that we saw before. It's not given, no, it's not given, Shalon. I'm telling you that this is 360, and if you divide 360 by 5, you get 72. Because what we're gonna do is, we're not gonna find the area of a pentagon. We're gonna find the area of 5 triangles. Instead, we're gonna use 5 triangles. So that's our strategy. Now the thing is that there's no numbers given. And what that's saying is, it doesn't matter how big or how small this picture is. No matter how large or how small the picture is, the proportion, that is the percentage of the area that is occupied by the pentagon, will always be the same. So what I'm going to do is, I'm not going to give any numbers here. Now, for those people that are a little bit insecure with that, you can put a 1 here. See where the R is? You could put a 1. In fact, if you want, I can answer the question as if it was a 1. So let's do that. Let's assume that R is a 1. See that here? Let's assume that R is 1. You don't have to do that though. So if you do that though, then what is the area of a triangle? If you remember from the cover of the booklet, the area of a triangle is this formula here. Remember that formula? It's that formula because you have the two sides and then you have the angle that's sandwiched. So you can do that over here. See, here's the two sides, and then here's the angle that's sandwiched or contained if you prefer. So that's going to be half 1 sine 72. And then the area of the pentagon is going to be 5 of those triangles. So does anybody have a calculator? Can someone do half sine 72? I need 4 decimal places, please. Can someone give me that number? 4 decimal places. Anybody there? Thank you. Is it 6 or 5 at the end? Okay. Now, take that and multiply by 5. Oh, you'll definitely need a calculator for this test, Denny. Okay, multiply that out there. Someone do that, please. Thank you, Zifeng. Now, what's the area of a circle? What's the area of a circle? Anybody have a formula for that? Who remembers formula for circle? Yeah, pi r squared. So that's pi r squared, but r is 1. If you round it, you get that. So there's the answer, people. We are inches away from the answer. Then you divide them, that's right. I'm just going to do it, I'm going to type this part. Can someone tell me that as a percentage? What's that as a percentage? 75 roughly? No, Denny, the radius is 1. The radius is 1, Denny. Because it goes from the middle to the thing, the middle to the edge. Thank you, 7568. I got the same answer. That's the answer, everybody. 75%. 75.68%. So that's the answer for part A. So you can do this question without this assumption. You don't need that assumption. So if you're wondering how would you do that without the assumption, I will copy and paste the answer right below. No, it's fine, but just the booklet says 4 significant digits. That's why. I think every question is 4 significant digits if you read the cover of the booklet. But that's fine. I'm going to show you, I'm just going to copy the answer here for the general case. But you're not responsible for it for today's class. I'm just going to put it out there. I just want to have it here so when you go to Blackboard later, you can see my answer. This is same answer without making assumptions. What I did here was I did not let r equal 1. See how I didn't put 1 for r, I left r everywhere? And what you notice is eventually that the r's cancel. These r's cancel eventually. So this r here that you get, it persists in the question, but the r appears on the top and the bottom. So then you don't, that the answer is right there. So that's the answer for the pentagon, the regular pentagon. For those that want to see the answer for the regular octagon, I'm sorry if I'm pacing myself a bit here, but I need to do the 4 questions within the hour. So I am just going to tell you what the answer is for the octagon. It comes down to a very simple modification there. Basically, replace all the 5s with 8s. If you go to the question, there's 5 sides, but with the octagon, there's 8 sides. And the reason I'm presenting the answer for part B only is because I want you to compare. Do you see that? Did the area percentage go up or go down? Did this increase or decrease? Yeah, it increased. That's right. And that makes sense because if you have a circle and the more sides that you put all the way through, the more it's going to fill up the circle. Because in a mathematical sense, as you approach an infinite number of sides, you actually will form a circle. Because a circle can be thought of as a polygon, a regular polygon, with an infinite number of sides. So a couple of questions to start off today's class that were a little bit unorthodox, a little weird. Here's a question that's a bit more traditional. It's something similar to what we did last booklet, and it involves angles of elevation. So this question is a lot of writing, but not anything individual that is really too dangerous. It's just a lot of writing. So we have this question involving angles of elevation with respect to a building. And you know that the overall distance at the base here from the farthest observer, so this is the person that's farthest away from the building, observing or measuring the angle of elevation of 38 degrees, they are 90 feet away from the building. So the question is to find the individual lengths that separate the 3 observers. So just imagine again, there's 3 people right here, 1, 2, 3 people that are surveying the building. And based on this information here, we're going to find out how far apart each person is with respect to each other and the building. In order to answer this question, it's beneficial to first find the height of the building. So it would be nice to find the height of this building H, because that will reveal a lot of the work that you need. So how do you solve this question? Well, you can think of it as 3 separate triangles, and I'm going to do that right now. I'm just going to do a little bit of housekeeping here to the diagram. So just bear with me for a second. This might take me a minute or two. So I want you to envision 3 triangles, and I'll show you the triangles in a second. I'm just going to do some deleting. So you have the big triangle. There's the big triangle. And then you have this medium-sized triangle. Don't really care about the 90 there. Then you have this little baby triangle here. So what do you think? What do you think? We kind of divided and conquered here. And that's what I would do. This is not necessarily the most efficient answer, but it really does, I think, improve our chances of succeeding. Let's get rid of this 58 here. We don't need it. So this length here is B plus C. This is C, obviously. And this is 90. These are in feet. And then we have the height across, and we have some angles. So I think you can see what's going to happen here. We're gonna divide and conquer the question. So which triangle should we start with? Should we start with the left one, the middle one, or the right one? Yeah, definitely with the 90, with the left one. So you can find the height first. So this is the part where, if you don't mind, I'm not going to write it by hand because it's going to take a lot of writing, and as you can see, sometimes with the stylus, it's very frustrating. So the first thing I'm going to do is get that height. So there's the height. I can scroll down here because we don't need that stuff anymore. Ultimately, we're trying to find A, B, and C. So that's step number one. And I'll number the steps for you as well. Step number one, get that height. So now we know the height. See, I'll just check it off. We know that, and we know that. So that's fantastic. Now, what do you do next? I'm not a fan of the middle triangle because it's B plus C. It's a little bit irritating. I think it would be easier for us to go for C. Do you see how it's a little bit simpler on C? Because we know this number here is 70.32. So it just fits in a little bit nicer. So yeah, we're going to go to the third triangle and deal with that now. So I have that ready on the side here. Just going to plop that in. Just like that. So that's step two. Now that you have the length C, now you need to find, so if I make a little checklist here, we need A, B, C. That's our little checklist. We got C. So now we need A and B. So I think Shalon is correct at this point. We want to go with B. So we'll go to the middle triangle. We'll go to this triangle now and get B. And there's no way to sugarcoat this one. The algebra on this one's a little bit tougher. Denny, I can't follow what that says. I think you're trying to say like SOH CAH TOA or something. Is that right? Okay, 90. So there's A, B, and C. So there's actually, it's A plus B plus C is 90. Remember, there's three numbers. So we're going to save that till the end. What you're dealing with, Denny, there is good. We're going to deal with that at the very end. It's the last step of the question. So the next thing I'm going to do here is get the length of B by using the middle diagram. This part's not fun. It may take a few people some time to really digest it because there's a little bit of algebra that's annoying. But let me walk you through it. So this is our step 3. So in step 3 here, I wrote tan. I think everybody in this audience is comfortable with tan because we have opposite and adjacent. So that's what this equation is. Now, looking at that, some people will get intimidated because they see all these letters. But I want to just focus on one thing, and then it'll be clear to you. See the tan 48 and the B plus C? We've done this trick several times already. what you can do is a little switcheroo. You switch them. You take the tan 48 and you take the b plus c and you switch them. And you see how they switched on the next line here? Now b plus c is here and tan 48 is down there. So if you do the switcheroo, then it allows you to get b plus c, because you know what h is, because h is given in the question. So now you know that b plus c is that. See, b plus c equals 63.32. So then what is b? B is 63.32 minus this number, and what that number is it's c. You're taking away c, and you get 19.38 feet. So on our checklist now, we know what b is. So what you mentioned in the chat there, Denny, would be the last step of the question. Right here. A is equal to 90 minus b minus c. So that's the very last step to finish off the question. And I did that earlier and got 26.68. And that's in feet. So that pretty much nails it. So hopefully nothing too stressful there. Just a lot of writing. And we can do our little checklist here. We have A now, so it's a good point to walk away from the question. Now, I did promise you 4 questions, and I want to make sure that I respect our time here, because I don't want to keep you beyond the fair amount of time that we have to have the lesson. So we're going to move on to the last question here, which is number 4. And we'll do a bunch more of these next time on Friday. So this question is not too bad. It's like a little bit algebra, but I'll walk you through it and we'll be okay. So this one I might just type out. It's nothing too dangerous. Any suggestions on here what you want to do? What should we do here? Yeah, we want to find x, yeah. So the question's asking us to find the length of the vertical side. So we actually want to find this length here. We want to find this length here, but we can't do that right away. So we're going to solve for x first, and then we can go back and do that later. So I'm going to try to type this one. I think we have enough time if I just type it. So using SOH CAH TOA, I noticed that cos of 31 is equal to x over x plus 3. Cos of 31, I'll just go with a decimal there. And then I'll cross multiply. So remember that 8572, that decimal there, is actually over a 1. And what you're going to do is you're going to cross multiply. And if you don't mind here, I'm just kind of cruising through it. Once you have that, we can distribute this decimal into the bracket. I am certain that we've done examples like this already. And you'll remember them back in the first unit, where we had a little bit of algebra, a little bit of flavor there, a little algebraic flavor going on. So what we're going to do now is move things around to get all the x's to one side. Now, that's what you'll get here. You see how the x's appear on just one side. To do this operation, remember there's a 1 in front of this x. So it's like saying 1x minus 0.8572x. So you just subtract those coefficients. So that would be like 0.1428. Now if you're like, I don't understand that, let me give you an easier question. Like this. 2 equals 5x minus 3x. What would you do? You would do 5x minus 3x. See, this question is similar to this question, except the right question here highlighted is just easy numbers. But don't let that scare you, because the numbers here, if they're decimals or if they're integers or whole numbers, it doesn't matter. It's just numbers that you follow the rules. So to get x, we have to divide here. Whoops. Like that. And eventually you'll get 1801 meters. And this represents kind of the worst part of the question. That's the tough part. But now we want to find the vertical side. So what you can do is you can go back to the original diagram and you can plug in 1801. So this is 1801. Whoops, 1801 meters. Can someone tell me what's this length? What's this length equal to? In the chat? Yeah, plus 3, exactly. Just add 3 to it. So that's 2101. And then this vertical side, which is what we're trying to find, I'm going to call that y. So this is the vertical side. I just called it y. So we can finish here by getting that vertical side. And you could use SOH CAH TOA, you could use Pythagorean Theorem, you could do a whole lot of stuff. I'm going to use tan. I'm going to avoid the Pythagorean Theorem just to give you some practice. But we didn't actually need the hypotenuse if you do it this way. You don't need the hypotenuse if you do it the way I'm showing you. But it doesn't harm us to do that extra practice there. So that's y equals 1801 and 31. And that equals 10.82 meters. So there you have it. We've conquered 4 questions, and we'll have another 8 to go before Friday. There may be the off chance that I might just record one of the answers from 6 to 9, one of the middle questions, just so that I can slow it down a little bit on Friday. But anyway, regardless, I think that you'll find the questions are not too much writing. There's only really one question that we're going to cover next time. That's a long question, a lot of writing. Yeah, if the letter's on top, you multiply. Exactly. Remember that pattern, Denny? If it's on top, you multiply. And if it's on the bottom, if the y was on the bottom, you would divide.